CNC routers are important tools in manufacturing, woodworking, metalworking, fabrication, education, prototyping, and custom production. These machines combine durable mechanical structures with computerized controls to create accurate and repeatable parts. However, modern CNC routers also contain a significant amount of electronic equipment. Understanding how these components are maintained, upgraded, reused, and eventually recycled can help businesses reduce unnecessary waste while supporting reliable production. CNC routers use programmed digital instructions to guide cutting tools through specific paths. These instructions control movement, cutting depth, speed, direction, and the sequence in which different functions activate. Small workshops and educational programs may use compact desktop routers, while industrial facilities often operate large machines for many hours each day. Depending on their design, CNC routers can work with wood, plastic, composites, foam, and certain metals. One of their main advantages is consistency. The same program design can be used to produce multiple matching components with precise dimensions. This can reduce production errors, unnecessary material use, and the amount of rework required. Although CNC routers are often viewed primarily as mechanical equipment, their precision depends heavily on computers, sensors, controllers, motors, power supplies, and communication systems. Every CNC router depends on coordination between its mechanical and electronic components. Design and toolpath files tell the machine where to move, how quickly to operate, and when individual functions should begin or stop. Controllers interpret these instructions and convert them into signals that the machine can follow. Motors then move the cutting tool along the programmed axes, while motor drivers regulate the electrical power needed for controlled movement. Sensors monitor position, speed, temperature, axis limits, and other operating conditions. Their information helps the system maintain accuracy and avoid misalignment or collisions. Displays, control panels, switches, and handheld pendants allow operators to supervise production, adjust settings, respond to warnings, and stop the machine when necessary. Because these systems work together, a problem with one electronic component can affect the accuracy and reliability of the complete CNC installation. A single CNC installation can contain a surprisingly large collection of electronic components. Control boards and processors manage machine instructions, while motor drivers regulate movement along the different axes. Power supplies convert incoming electricity into the levels required by controllers, motors, sensors, displays, and other components. When a power supply becomes unstable, it can cause shutdowns, communication errors, or inconsistent equipment behavior. Screens, switches, control panels, and handheld pendants provide the operator with access to machine settings and diagnostic information. Repeated physical use can gradually wear out buttons, touchscreens, connectors, and emergency controls. Industrial control cabinets may contain drives, relays, circuit boards, wiring assemblies, cooling fans, and communication equipment. External computers, monitors, networking devices, digital measuring tools, and battery backup systems may also support the router. When the CNC machine is retired, these electronics should not be treated as ordinary industrial scrap. A CNC router does not always become obsolete because it can no longer cut material. In many cases, the frame, rails, and mechanical movement systems remain strong while the electronics become outdated. Older controls may have limited compatibility with current design software. Updated applications may require newer operating systems, processors, communication interfaces, or security features. Replacement control boards, drives, sensors, and displays can also become difficult to obtain when manufacturers discontinue support for older machines. Limited parts availability can increase repair expenses and production downtime. Businesses may upgrade their equipment to gain improved precision, faster production, greater automation, better energy efficiency, or stronger network integration. However, electronic obsolescence does not always require replacement of the entire CNC router. Selective upgrades may allow the durable mechanical structure to remain in service while its computer, controls, sensors, or communication systems are modernized. Manufacturing environments can be demanding on CNC electronics. Machines may operate for extended periods while exposed to vibration, dust, temperature changes, and airborne particles created during cutting. Vibration can gradually loosen terminals, connectors, wiring assemblies, and electronic mounts. These loose connections may cause intermittent errors, unstable power, inaccurate movement, or unexpected shutdowns. Wood, plastic, composite, and metal particles can enter control cabinets and computer enclosures. Dust can accumulate on circuit boards, block ventilation, and reduce the effectiveness of cooling systems. Cooling fans and filters require particular attention. When airflow becomes restricted, power supplies, drives, processors, and control boards may operate at higher temperatures. Buttons, switches, touchscreens, control pendants, motors, and drives also experience repeated use during production. Routine cleaning and inspection can help identify gradual wear before it results in a major equipment failure. Regular maintenance should include both the mechanical and electronic areas of the CNC router. Wiring, connectors, sensors, switches, motors, power supplies, cooling fans, and control cabinets should be inspected periodically. Electrical connections should remain secure and protected from dust, moisture, vibration, and accidental impact. Fans, filters, vents, and cabinet openings should also remain clean and unobstructed. Operators should listen for grinding, rattling, buzzing, or other unusual sounds. Changes in motor noise, vibration, speed, positioning, or cutting accuracy may reveal a developing mechanical or electronic problem. Repeated alarms and error messages should not be ignored. Recording warning codes and the conditions under which they occur can help maintenance personnel diagnose recurring failures. Maintenance records should include inspections, repairs, component replacements, software changes, and performance problems. This information supports future decisions about repair, modernization, and equipment retirement. Employees are often the first to notice unusual machine behavior. Clear reporting procedures allow minor issues to receive attention before they interrupt production or damage surrounding components. Replacing an entire CNC router is not always necessary when a single component fails. A strong mechanical structure may remain useful after a computer, display, sensor, motor, drive, or power supply requires attention. Updating the control computer can improve software compatibility and processing performance. Before removing the old computer, design files, machine settings, production programs, and configurations should be transferred and verified. Damaged displays and control pendants may also be replaced individually. New interfaces can restore normal operation and provide better access to machine settings and diagnostic information. Sensors, motors, drives, communication modules, and power supplies can sometimes be repaired or replaced with correctly matched components. These targeted upgrades can improve performance while reducing the amount of equipment entering the waste stream. Repair decisions should still consider the overall condition of the machine, parts availability, downtime, long-term reliability, and future production requirements. The goal is to avoid premature disposal without repeatedly investing in equipment that can no longer meet operational needs. CNC operations depend on more than the router itself. External computers may store design files, production programs, specialized software, and machine configurations. Monitors, handheld pendants, external drives, networking devices, digital measurement tools, battery backups, and diagnostic equipment may all be connected to the production system. When a workspace is modernized, these smaller devices can easily be overlooked. Some may remain compatible with the new equipment and should be retained for continued use. Others may be damaged, technologically obsolete, or no longer supported. These devices should be separated from ordinary shop waste and evaluated for responsible recycling. An organized inventory can identify which accessories belong to each CNC machine, whether they remain functional, and whether they can be reused elsewhere. This prevents useful equipment from being discarded automatically simply because the primary router is being replaced. Modern CNC systems can store valuable and sensitive operational information. Design files may contain custom parts, prototypes, manufacturing methods, or confidential customer projects. Machine configurations can include axis limits, calibration information, tool settings, communication details, and customized performance adjustments. Production programs and toolpaths may reveal how specialized components are manufactured. Connected computers and controllers may also retain network names, addresses, credentials, and other facility information. This data should be reviewed before any equipment leaves organizational control. Important files and configurations should be transferred to an approved storage location and checked to confirm that they remain accessible. Sensitive or proprietary information should then be appropriately removed from computers, drives, controllers, and other data-bearing components. Responsible equipment retirement includes both physical electronics management and digital information protection. A computer should not be sent for reuse or recycling before the organization determines what information it contains. Planning should begin before a CNC router completely fails. Early preparation gives the facility time to evaluate the equipment, protect important data, identify reusable components, and coordinate transportation. The router should be assessed as an integrated system containing mechanical structures, motors, computers, controllers, displays, sensors, power supplies, wiring, and accessories. Working components may support another compatible machine. Motors, control pendants, displays, sensors, and power supplies selected for reuse should be tested, labeled, documented, and stored securely. Electronic components should be separated from ordinary metal and industrial scrap. Circuit boards, processors, displays, controllers, communication devices, and data-bearing equipment may require different end-of-life pathways. Retirement records should identify what was removed, retained, repaired, sold, reused, or prepared for recycling. This documentation helps the organization maintain an accurate equipment inventory. A licensed recycler should be contacted in advance to confirm accepted materials, transportation options, fees, preparation requirements, and data management services. Operators, maintenance personnel, and management all have important roles in responsible CNC equipment management. Operators interact with the machinery regularly and may be the first to notice unusual sounds, vibration, heat, errors, or changes in cutting accuracy. Maintenance personnel can evaluate whether a component should be cleaned, repaired, upgraded, or replaced. Management considers production requirements, operating costs, reliability, energy efficiency, and future technology needs when deciding whether equipment should remain in service. Employees should understand that obsolete computers, controls, sensors, cables, displays, and circuit boards do not belong in ordinary shop waste. Clearly labeled collection areas can prevent accidental disposal and keep reusable accessories organized. Future CNC routers will likely contain more sensors, intelligent monitoring systems, automated controls, and digital communication technologies. These improvements can increase productivity and precision, but they will also increase the electronic content of manufacturing equipment. Routine maintenance, selective upgrades, organized inventories, data protection, component reuse, and responsible recycling will become increasingly important as CNC technology continues evolving. CNC routers should be viewed as integrated systems containing both durable mechanical structures and sophisticated electronics. Responsible lifecycle management can help businesses maintain dependable production, extend equipment life, preserve useful components, protect sensitive information, and reduce unnecessary electronic waste. When CNC computers, control boards, displays, sensors, drives, and related electronics reach the end of their practical lives, proper planning can help direct them away from ordinary industrial disposal. Reach us by phone, email, or through our website. Precision should guide more than production. It should also guide how every CNC electronic component is maintained, reused, and responsibly recycled.